Bombardier Belfast specialise in the design, development and manufacture of complex aerostructures. We are the largest manufacturing organisation within Northern Ireland and as such the largest inward investor. Modern aircraft increasingly incorporate larger engines to improve the efficiency with which the aircraft operate. These larger or high bypass ratio engines have a nacelle around their structure which significantly contribute to the weight and performance of the overall propulsion system. The aim of the project was to develop analytical and experimental technologies to improve how we design the nacelle to make it more efficient.
We're here at the Kemble Engine Test Laboratory where S&C Thermofluids carried out the experimental side of some of the SANTANA project requirements, such as anti-icing and thrust reverser measurements. We were looking at the front of the engine where ice can form. We were trying to provide information on how well the system to prevent ice from forming would perform, and at the back end of the engine where there's a thrust reverser to try and slow the aircraft down on landing, we were looking at different aspects of that performance. What we were able to learn from doing the project was that we were able to understand how we could construct a method of measuring anti-icing system performance, creating the whole flow field for a very large engine nacelle, and also how we could supply flow to a thrust reverser and do thrust reverser measurements in-house.
So the model that I'm standing in front of was built for the SANTANA project and specifically for the work on plume trajectory. We ran this as a scaled version of a full-size aircraft in landing conditions. So we supplied it with air going over the top of it as if it was landing on a runway, and we also had a rolling road underneath it, so you had the full system.
The project has allowed us to develop our analytical skills so we can better model and predict the performance of the nacelle. By such we can make the nacelle more efficient, and in doing so improve the efficiency of the aircraft, reducing fuel burn, reducing weight, reducing noise, reducing emissions. I think what the ATI bring through providing that support and funding is the ability to leverage and exercise those research and development capabilities.